All right, we are ready to start Unit 2. If you remember, in Unit 1, we talked all about how we were collecting data. So in Unit 2, we're now going to talk about exploring data. So what are we going to do with that data that we've collected? We're going to start in Section 2.1 by focusing on analyzing what's called categorical data. So in order to study categorical data, we first need to consider a few different things. First is the individuals. So the individuals are basically everyone that you want to collect information from. And so that's what we would think of as probably the who. So if you're thinking of like the 5 W's, who, what, when, where, why, and then how, I think is the last one. The individuals are the who part. Who do you want to get information from? The variable then is kind of the what. It's the information that you collect. It's the categories that you're separating it into. So there's going to be kind of two different types of variables that we're going to look at. One of which we're going to focus on today, which is categorical variables. The other we'll talk about a little bit later in this unit, which are the quantitative variables. So first off, categorical variables are the variables which you can separate into category. Sometimes these are thought of as the qualitative variables. So this would be stuff like color, or maybe sex, or maybe political party. So the different types of data that you would collect based on those would be considered categorical. Quantitative then are more variables which can be described as by numbers. So it should make sense to find an average for this type of data. So we're talking about stuff like maybe GPA, or height, or age, and stuff like that. So it has to make sense. For quantitative variables, you have to be able to find an average. So when you're trying to decide between categorical and quantitative, ask yourself, would it make sense to find an average for this set of data? If the answer is yes, then it's quantitative. If the answer is no, then it's categorical. Now, do we ever use numbers to describe the values of a categorical variable? And the answer there is sure. To give you a real easy example, think about zip codes. So when you think about zip codes are a number. Like for Shawnee Mission North, our zip code is 66202. My zip code growing up was 66216. So there's all these different zip codes, but would it make sense to find an average zip code? And the answer there is no. You can't find an average zip code. That would be an example of a categorical variable which uses numbers to describe it. Now, do we ever divide a distribution of quantitative variables into categories? The answer to that is also sure. Think about ages. You could separate age groups into the 0 to 10 age group, 11 to 20 age group, 21 to 30 age group, and so on. So even though ages would sometimes be considered quantitative and you could find an average age, you could also separate them into categories and make it into a categorical variable. Now, we're going to be looking at a lot of distributions, and so distributions are just kind of any visual display of data. We'll talk about kind of the differences, the advantages and disadvantages of certain types as we go through this unit. As an example, here is a display of data, which is just in the form of a table. We've got 10 randomly selected U.S. residents from the 2000 census. We're given their state, their number of family members, age, gender, marital status, total income, and travel time to work. So first, who are the individuals in this data set? Who did we get this data from? That would be the 10 U.S. residents that were a part of this census and a part of this sample that we got. So the 10 U.S. residents would be our who. For the next question, for part B, what is being measured? So what are the variables that we're looking at? Well, those are what we used as our labels up at the top. So we're measuring or we're collecting data on what state they're from, the number of family members, what their age was, what their gender was, marital status, their total income, and then their travel time to work. Now for each of these, let's decide whether it's categorical or quantitative. So for categorical, I'm just going to write C. For quantitative, I'm going to write Q. So first off, for state, would it make sense to find an average state? No, so that would make this a categorical variable. For number of family members, could we find the average number of family members for each of these residents? And sure, that would make it quantitative. Now for age, notice that they gave us the actual age. They didn't give us an age group. That's a big difference. So would it make sense to find an average age? Yes, that makes this quantitative. For gender, would it make sense to find an average gender? No, that's going to be a categorical variable. For marital status, whether they were married, separated, never married, and single, would it make sense to find an average? No, so that would be categorical as well. For income, would it make sense to find an average income level? Sure, quantitative. And lastly, for travel, would it make sense to find an average travel time to work? Sure, that makes this a quantitative variable. All right, so now let's just describe the individual in the first row. So we're just going to write a few sentences about this person right here. So we can first off say that she is an individual from Kentucky. I say she because her gender was female. Let's see, she was married, or is married, I should say. So she is married with a total of 2 family members. It looks like she's also 61, so let's just add that in. So she's married with 2 family members and is 61 years old. On average, she drives 20 minutes to work each day. And earns about $21,000 per year. All right, cool. So when we talk about displays of data, in addition to kind of that table that we saw, we've got some additional kind of ways that we can display data. One of which is a frequency table. So a frequency table just displays the categories as well as the counts, which are sometimes called frequencies. Whereas a relative frequency table is similar. It displays the categories, but instead of giving the actual number, it's going to give the percentages instead. So when you think of frequency table, maybe we're thinking about marbles in a bag. We've got red, blue, and green marbles. And maybe we had like 2 red, 3 blue, and 5 green. So here would be your frequency table. Would be 2 red, 3 blue, 5 green. The relative frequency table would say that 2 out of the 10 were red, so that would be 0.2. 3 out of the 10 were blue, so that would be 0.3. And then 5 out of the 10 were green, so that would be 50% were green. So the difference is this is frequency, this is relative frequency. So frequency, you actually know the number in the bag. Relative frequency, you just know how many were in there as in terms of a percentage. Which we also have pie charts and bar graphs. Pie charts have to be used to show parts of a whole. As remember, pie charts are the ones that get divided up kind of like this and kind of show you the different parts of a whole for the pie. Whereas bar graphs are going to be typically better for comparisons and are going to look something kind of like this. Notice that in a bar graph there are spaces in between each of the bars. That's important because later on in this unit we're going to be talking about histograms, and in histograms there is not space in between the bars, and so we'll have to make sure we can distinguish between the two. So when is it better to use a relative frequency table versus a frequency table? Well, relative frequency is better when you want to compare parts of a whole. Now, what is the most important thing to remember when you're making pie charts and bar graphs? Well, the important thing is for pie charts, you need to make sure that it's parts of a whole. So again, pie charts, parts of a whole. Whereas bar graphs are going to be easier for comparisons. So again, that's kind of based on those definitions and what I gave to you up above. So why do statisticians prefer bar graphs? Again, the answer to this question is that they are easier for comparison. Now, one big key to all of this, as we go throughout this unit, is to make sure that you always label everything. So make sure you label the bar graphs, the pie charts, the percentages, all of that sort of stuff. Now, just to give you a comparison and why bar graphs are sometimes preferable to pie charts, is when you're looking at a pie chart, for example, when you're looking at, let's say, country versus religious music. When you're looking at that on a pie chart, it's hard to tell without the percentages which section of that pie chart is bigger than the other. In fact, you almost could say that country and religious look to be equal. It becomes a little bit easier to at least compare when you're looking at a bar graph. So when you look at this kind of height of the country music, so right about there, you can now see that, kind of drawing that line across, that there actually is slightly more of country music on the radio stations than there is religious. So it does make it a lot easier to compare kind of the two when you're looking at a bar graph versus a pie chart. All right, I believe that's it for this section of the notes. In the next section, we're going to talk about misleading graphs, what makes a graph misleading, and how we can kind of avoid that when we're making our own graphs. Until then, have a good rest of your day.